Hello and welcome. Today's topic is 2 LED blink using PIC12F629. PIC12F629. The PIC12F629 is an 8-bit microcontroller made by Microchip Technology. It's part of their PIC12 family, known for its small size and low cost, which makes it ideal for simple embedded applications. Key features of PIC12F629. Core, 8-bit PIC architecture. Program memory, 1K words of flash memory. RAM, 64 bytes. EEPROM, 128 bytes non-volatile memory. Operating speed, up to 20 MHz with internal or external oscillator. I/O pins, 6 general-purpose I/O pins. Timers, one 8-bit and one 16-bit timer. Analog comparator, 1. Watchdog timer, yes. In-circuit serial programming, ICSP supported. Internal oscillator, 4 MHz, no external crystal required. Package, typically available in an 8-pin DIP or surface mount package. Common uses: simple control systems, sensor interfacing, remote controls, hobby electronics and DIY projects. Light automation. MPLab X IDE. MPLab X IDE is an integrated development environment (IDE) created by Microchip Technology for developing applications for their microcontrollers like PIC, DSPIC, AVR, and SAM devices. MPLab X IDE is the main software you use on your PC to write, compile and debug code for Microchip microcontrollers like the PIC12F629. Simul IDE. Simul IDE is a simple real-time electronics simulator mainly used for learning and experimenting with microcontrollers, basic circuits, and logic components. It's lightweight, beginner-friendly, and great for visualizing how electronic circuits work without needing physical components. Simul IDE lets you simulate electronic circuits and microcontroller projects easily, making it great for students, hobbyists, and beginners learning embedded systems. Let's start the project. Step 1. Install the tools. 1. MPLab X IDE, to write and compile code. 2. XC8 compiler, used with MPLab X to compile C code for PIC. 3. Simul IDE, to simulate the hardware and run the .hex file. Step 2. Create and compile your code in MPLABX. 1. Open MPLab X IDE. 2. Create a new project. Select Microchip Embedded. Application projects. Choose PIC12F629 as the device. Select Tool, Simulator. Select XC8 as the compiler. Type project name, LED Blink 2. Finish. 3. C code for Blink LED on GP1 and GP2. Hashtag include less than XC, H greater than. Configuration bits, internal oscillator. Watchdog timer off, etc. Hashtag pragma config FOSC equals intarcio, internal RC oscillator. I/O on GP4, GP5. Hashtag pragma config WDTE equals off, watchdog timer enabled, disabled. Hashtag pragma config PWRTE equals off, power up timer enabled, disabled. Hashtag pragma config MCLRE equals off, GP3, MCLR pin function is digital I/O. Hashtag pragma config boron equals off, brownout detect disabled. Hashtag pragma config CP equals off, code protection disabled. Hashtag pragma config cpd equals off data code protection disabled. Hashtag define underscore xtal underscore freq 4 million 4 MHz oscillator frequency. Void main, void. Set GPIO pins as output. TRISIO 0 equals 0, GP0 is output. TRISIO 1 equals 0, GP1 is output. TRISIO and equals 0 B11111001, GP1 and GP2 is output redundant safety. CMCON equals 0x07, disable comparators. While 1, GP1 equals 1, turn on LED 1. GP2 equals 0, turn off LED 2. Underscore delay underscore MS 500. GP1 equals 0, turn off LED 1. GP2 equals 1, turn on LED 2. Underscore delay underscore MS 500. Closing curly bracket. 4. Build the project. This will generate a hex file in the dist default production folder. Step 3. Open Simul IDE and simulate. 1. Launch Simul IDE. 2. From the sidebar, drag components into the workspace. A PIC12F629 under MCUs. Resistors. LEDs. A power source and ground. 3. Connect wires. Connect GP1 pin 6 to the resistor. LED. GND. Connect GP2 pin 5 to the resistor. LED. GND. 4. Load your .hex file. Mouse right-click on the PIC12F629 in the circuit. In the Properties panel, click the Load Firmware. Load your .hex file. 5. Click Run in Simul IDE and you should see the 2 LED blink. Thank you for watching.